Welcome back, everyone. In today's video, we are diving into the ultimate cheat sheet for calculus, the standard formulas of integration. Mastering these formulas is the key to solving complex calculus problems quickly and accurately. We start with the fundamental power rule, where the integral of x to the power of integral of x to the power of n equals x to the power of n plus 1, divided by n plus 1. Next, let's look at the basic trigonometric functions. The integral of sine x is negative cosine x, and the integral of cosine x is simply sine x. For tangent x, the result is log secant x, while cotangent x integrates to log sine x. Moving on to secant and cosecant, the integral of secant x gives us log of secant x plus tangent x, and cosecant x results in log of tangent x over 2. Now let's look at inverse trigonometric and special algebraic forms. The integral of 1 over a squared plus x squared gives us 1 over a times inverse tangent of x over a. If we have 1 over x squared minus a squared, it integrates to 1 over 2, a times log of x minus a over x plus a. When dealing with square roots in the denominator, 1 over the square root of a squared minus x squared becomes inverse sine of x over a. On the other hand, if it's the square root of x squared plus or minus a squared, the result is log of x plus that exact square root term. Finally, let's look at exponential functions in the famous product rule. The integral of e to the x remains e to the x, while a to the x becomes a to the x divided by log a. When you have a product of two functions, we use the integration by parts rule. The working rule is simple. Take the first function multiplied by the integral of the second function, then subtract the integral of the derivative of the first function multiplied by the integral of the second function. When we integrate 1 over a squared minus x squared with respect to x, where x is less than a, the result is 1 over 2a times the natural log of the absolute value of a plus x over a minus x, plus the constant of integration c. Next, let's look at integrals involving square roots. The integral of the square root of x squared plus a squared with respect to x is equal to 1/2 times the quantity x times the square root of x squared plus a squared times the natural log of the absolute value of x plus the square root of x squared plus a squared. Similarly, if we change the sign inside, the integral of the square root of x squared minus a squared follows a very similar pattern, giving us 1/2 times x times the square root of x squared minus a squared times the natural log of the absolute value of x plus the square root of x squared minus a squared. Lastly, for this group, the integral of the square root of a squared minus x squared equals 1/2 times the quantity x times the square root of a squared minus x squared plus a squared times inverse sine of x over a. Moving on to basic polynomial and trigonometric integrations, which form the foundation of calculus problem solving. The integral of secant squared x is simply tangent x, while the integral of cosecant squared x gives us negative cotangent x. Furthermore, the integral of the product of secant x and tangent x evaluates to secant x. And finally, the integral of cosecant x times cotangent x is equal to negative cosecant x. Don't forget to add your constant of integration, c, to all these indefinite integrals. The integral of 1 over the square root of 1 minus x squared dx gives us inverse sine x, while integrating minus 1 over the square root of 1 minus x squared dx results in inverse cosine x. Similarly, the integral of 1 over 1 plus x squared dx equals inverse tangent x, and adding a negative sign to that gives us the integral for inverse cotangent x. Moving on to the secant and cosecant forms, integrating 1 over x times the square root of x squared minus 1 dx yields inverse secant x, whereas the negative version integrates to inverse cosecant x. Next, let's explore a very important and frequently tested special form involving exponential functions. When you encounter an integral in the form of e to the power of x open bracket f of x plus f prime of x close bracket dx, where a function and its derivative are added together inside the bracket next to e to the power of x. The final answer simplifies directly to e to the power of x f of x. This is a massive time saver during exams.